Hi, good afternoon. This is Mr. Cassidy, and today I'll be covering PEMDAS, the order of operation. And now, probably for some of you, you're like, okay, this is old news. I've covered this before. It's pretty simple. And for some of us, it's a good place to start out. Maybe you've made mistakes with PEMDAS before. I always like to start IM1 with this because there are several areas that easily lead to mistakes as we get into algebra. And this is, if we clear them up now and understand them well now, then it can save us a lot of agony in the long run. So here I've just checked to make sure I've got my pen. Awesome, let's begin. So PEMDAS. PEMDAS, a lot of people remember it by saying please, excuse, my dear, and Sally. And PEMDAS is the order of operations that we use in math. So it tells us what to do first. So here's Aunt Sally, and let's go ahead and jump into our first order of operations, the P. P is for parentheses. Parentheses means we do all grouping symbols first. That means we might do our parentheses if they have brackets, or even these squiggly line brackets, it still counts as a group. And so we're going to do whatever is inside that group first, solving that inside part first. If it has more than one set, let's say we had a problem like this, and then it was like this. So we have like 1 plus 1 minus 3. We're going to solve the inside of this parentheses first because it's a parentheses inside a bracket. And so we'll work our way outside with all parentheses and grouping symbols. Excuse or E stands for exponents. So that would mean to evaluate any powers, square any numbers. If you have 2 to the third power, that means now exponents we cover a lot more in depth later in the year, but that means we multiply this number 3 times. So we do 2 times 2 times 2. For now, really what you need to know is that like if we put squared, like 7 squared, that means we would square it and get 49. That's 7 times 7. All right, third, left to right. We do multiplication division left to right. So our MD stands for multiplication division. And fourth, addition subtraction, that also goes left to right. Let's get into some examples. Okay. Oh, helpful hint. Fraction bars, radical symbols, and absolute value symbols can also be used as grouping. So, for instance, this fraction, this means 3x is divided by 9, and the 6 here is divided by 9. It means this whole top part is divided by 9. So this is taken as a separate group of numbers where the top is one group being divided by 9. Here, absolute value bars. Absolute value bars means the inside here should be evaluated first. In that case, we do 5 minus 10 is negative 5. And then we would evaluate the absolute value bars before adding the 20. So we would get 20 plus positive 5, because absolute value means just switch the sign to positive. So again, we get further into absolute value things later in the unit, but I just want you guys to know that that works like a grouping symbol. It means do the inside first before you do any positive, negative changes. Last, square roots. Now, this is a very fancy thing, 10 plus or minus square root of b squared minus 4ac. All of this stuff inside is in a square root symbol. And a square root symbol we get into later in the year, but for now, what you need to know is that that means that is a group that is all together. Those numbers effectively have a parentheses around them. All right, so let's start with some basic ones here. Simplify each expression. So you could write PEMDAS up at the top if it helps you. Let me just find my cursor here, PEMDAS. And remember, M goes with D, A goes with S. So here in this case, I see no grouping symbol, so you wouldn't start there. You would start, check for exponents, no exponents or square roots. So now I'm going to go to MD, multiplication division. I see 2 times 3, so that's where I'm going to start. In this case, I would solve that first, and I like to bring it down, write a new row, 6 here, and I copy everything else, 15 minus 6 plus 1. All right, so once I've done that, I'm going to work now. Now I'm at my addition subtraction step. I'm going to move left to right. So that means first I'm going to solve 15 minus 6. That part is 9. Then I'm going to add the 1, bring those together, and get 10. So I'm working left to right across the problem when I'm at multiplication, when I'm at the MD step and the AS step. All right, you could try letter B here on your own, and then I'll solve it. Go and type your answer in. Okay, so in this case, we do have an E for exponent to start our problem off. So I'm going to start with this 3 squared. That means 3 times 3, which is 9. Okay, I'm going to copy everything else because that's how I play it safe. Okay, I move on to MD, multiplication and division. I notice I've got some division here, so I'm going to group that and do the 10 divided by 2 first. We would get 5. And now I have 12 plus 9 plus 5. I'm going to work left to right in this case for addition and subtraction. And I'd get 21 plus 5 is 26. All right, let's carry on. Ooh, look at this doozy. Let's work through the order of operations to try to simplify this problem. So, try to think to yourself, what should you do first in this problem? Well, first thing would be parentheses. And I notice here I've got some parentheses, negative 4s in them. Can I simplify anything in that parentheses? I can't. I can't do anything here. So I'm going to just leave that as it is and move on to exponents. I notice I've got an exponent here. I've got 4 squared. So I'm going to rewrite the whole problem after I've solved that. 2 times negative 4 plus 22 over 4 squared is 16 minus 9. Now, what's going to come next? We've covered our exponents. Check that off your list. Now we've got MD, multiplication and division. Well, I've got one multiplication problem because, again, some of this may be review, some of this is new, but the 2 is smushed up against the negative 4 in parentheses. That effectively makes it multiplication. Anytime we have a number 3 parentheses up against it, all that means that can be rewritten as a multiplication problem. 3 times 5. 3 groups of 5 is the same as 3 times 5. So here we have 2 groups of negative 4. So I'm going to solve that and rewrite negative 8 plus 22 over 16 minus 9. Now, some of you guys may see the negative 8 and the 16 and be like, oh, I can simplify that. I can make a 1 on top and a 2 on the bottom. But you'd be jumping ahead. Remember that fractions are like groups. It's like there's a grouping symbol above and a grouping symbol below. We should simplify those before we move on. So I'm going to do my addition and subtraction step on the top, and I would get here negative 8 plus 22. That would be 14 is on top. And on bottom, 16 minus 9, that is a 7. And now I can simplify the fraction. Since all that's left is 14 divided by 7, I would get 2 as the answer because I can simplify that fraction. Now, some of you guys are like, well, wait, he did addition and subtraction before he did division. You're right. But that's because a fraction is treated like a group. Here, a fraction like this, a big division symbol, it's basically saying take this whole group of numbers and divide it by this whole group of numbers. And so we treat them separately. We do this first before we move to this division step of the whole fraction. Okay, let's move on. D. Go ahead and simplify this one. Try it out. You could punch in your number, whatever you get. Ooh, another bit of review. Remember, to divide a fraction, we're going to multiply by the inverse. So we're going to do 8 times 2 over 1 times 3. This is what we call the dot operator. Dot operator just means multiplication. It's just another way of writing multiplication in algebra. So in this case, I'm going to move left to right. Now I've got a bunch of whole numbers and then one fraction, so we can sort of change them all into fractions. 8 over 1 times 2 over 1 times 3 over 1. Actually, they're all over 1. They're all whole units, so we can ignore the bottom altogether. It's 8 whole units times 2 whole units times 3. And if we move left to right, we would get 8 times 2 is 16 times 3 equals 16 times 3 is 48. And there we go. So in this case, everything was multiplication and division. The only thing I did was I changed, since it was dividing a fraction, I changed it to multiplication, and then I worked left to right. And I changed, when I'm dividing a fraction, multiply by its reciprocal, or the flipped over version. Okay. Next, 3 times the square root of 50 minus 1. This is another thing we see sometimes in algebra. It's not as common this year, but if you have a number, 3, and then we have a square root symbol right next to it, it's sort of like we have a parentheses next to it. It's sort of saying, hey, do this first and then multiply it by 3. So what we're going to do is we're going to do the inside first. In this case, I would take square root of 50 minus 1 is 49. Simplify that inside. And the square root of 49 means what times what is 49? In this case, it would be 7. So we get 3 groups of 7, which is 21. Okay. All right, simplify the expression. Here you've got a lot to do. So, where should we start? Well, let's start with the exponent. Parentheses first, right? So here I've got 5 plus 2. I'm going to solve that first, and I'm going to get 7 there. I'm going to recopy everything else. That's the safest thing to do with these problems. Negative 2 to the third minus 3. Okay. So what do I do next? Well, we've done our P. The other parentheses just have one number inside them, so we can't do anything there. We're next going to move on to E, exponent. So here we've got negative 2 to the third power. That means negative 2 times negative 2 times negative 2. Well, in this case, let me copy the top. 7 times negative 8 over negative 2 to the third power is going to be a negative 8 minus 3. Okay. So you might be wondering, okay, what do I do on top or bottom next? Honestly, it doesn't matter to me as long as you do them first. So we're going to treat this like a grouping symbol. On top, here I'm going to actually use a bracket on the outside of the parentheses. And here I can put parentheses around the bottom. And so I'm going to do each of them separately. 7 times negative 8 is negative 56. And negative 8 minus 3 is negative, let's see here, negative 11. All right. That's pretty much as simple as I can get this, except there's one final thing I could do. Negative divided by a negative is a positive, and so we could just simplify it. Improper fractions are actually pretty commonly used in algebra, so we can just leave it like this, 56/11. Remember that old rule as well, just quick reminders, negative times negative equals positive, and positive times positive equals positive, and positive times negative equals negative. All right, moving on. So why don't you try these two, see if you get it. I'll solve them in just a second. All right, so in problem 1, we've got a big parentheses, and I notice that I've got a numerator that I need to simplify first. So I'm going to simplify the numerator. 3 plus -7 is -4 over 12 is now what's inside. And I'm going to group that separate and multiply it by 12. Now, if it helps, we can make that 12 over 1 and multiply it by -4 over 12. In this case, we could cancel the 12 divided by 12. That's just a 1. And we would get -4 as our answer. Okay, next problem, number 2. Now this is a classic problem. It has an area that many people make mistakes in. I'm going to solve the inside here first. 7 minus 5 is 2. And I'm going to copy the -4 outside and copy the 26. You'll hear me sometimes call a number -4. Like, I look at that symbol and I sort of think of it as part of this number. So I may refer to it as a -4, not a +4. All right, so in this case, we've got 26 minus 4 times 2. Now, the problem is many people will jump this and do 26 minus 4 is 22, but that would be wrong. What we want to do is our multiplication division first. We're going to do 4 times 2 and get 8. We're going to leave the subtraction symbol, leave the 26, and now we have 26 minus 8 is 26 minus 8 is 18. So there you have it. Our final 2 problems, -4 and 18. I thank your minds and your hearts, and I wish you a good math afternoon. Bye.